Personal protection is essential to avoid the contamination of our cultures. We work in between the alcohol lamps where no microorganism is present. We add water and MS media into a pot. We heat and agitate until MS media is completely dissolved. Then we add the agar. We have to wait until the first boiling bubbles and then turn the heat off. To sterilize the flask, we put them upside down in a pot with water. We have to heat this water so that it starts boiling. We're gonna wait until the water goes up about 2 times, and then the flasks are ready and sterilized. We also have to put the plastic lids in the boiling water just for a few seconds so that they can be sterile too. To sterilize the plastic container, we're gonna put a little bit of water into the container. Then we're gonna put it inside a plastic bag, and we're gonna put it in the microwave for about 2 minutes. To transfer the media, we're gonna put the hot media that just came out of the pot into the sterilized flasks. We're gonna do this with the help of our sterilized plastic container so that we can put 25 milliliters in each flask. Both flasks must be wrapped in plastic and leave to cool at room temperature. When it's already at room temperature, we put it in a fridge overnight to let the agar solidify. As the seeds, we're gonna do a mix of domestic bleach, detergent, and water. We're gonna put the seeds inside this mix for about 10 minutes with constant agitation, and then we're gonna rinse them with sterile water. We're going to grab our sterile seeds with tweezers that were previously rinsed with alcohol, and we're gonna put them inside our sterile media. Once the seeds are in the media, we're gonna put the lids in the flasks and we're gonna cover them with plastics. We're gonna put both flasks inside a plastic container to maintain humidity. They are going to be kept at room temperature and with indirect light. On day 1, we just inoculated our media, so we can see no germination. Day 3, we can see that one of the seeds has started to germinate. On day 4, we can see a shoot and root from one of our seeds, and 2 others of our seeds are starting to germinate. On day 6, our last day, we can see that 3 of our seeds have shoots and roots, and the other ones are germinating as well. Overall, our homemade experiment was a success. We were able to germinate wheat seeds without any contamination in our media.
Homemade seed culture with peas. Here are the materials that we are going to use: chlorine, iodine solution, gelatin, fertilizer, water, coconut water, tweezers, and gloves. First, clean the peas with 10% chlorine solution for 5 minutes. Then immerse the peas in 1% iodine solution for 2 minutes. For the media, in 1 liter of water we put 30 grams of gelatin, 25 milliliters of fertilizer, and 50 milliliters of coconut water. When the gelatin is completely dissolved, we put it on a pressure cooker for sterilization, with some flasks and tweezers. We use the burner from our kitchen to avoid any contamination and proceed with the inoculation of the peas in the flasks. All of the instruments used during the experiment was sterilized with alcohol in 70% and burned in the burner. This picture is after 3 days of inoculation, and the flasks doesn't show any kind of contamination and it started germination. Unfortunately, the media started becoming really liquid because of the temperature of the days that have passed. So I decided to start new media with 40 grams of gelatin instead of 30. With this adaptation, the media was a little bit more solid, and also in 3 days we can evidence some germination from the peas. And during the whole experiment, we didn't evidence any kind of contamination.
Okay, so what I'm gonna do now is I have my sugar dissolved in my 45 milliliters of potable water. I have the beaker where I'm going to measure my 10 milliliters that I'm afterwards going to pass to my small Gerber containers. Okay, so as you can see now I have reached my 10 milliliters of my water sugar solution, and I'm gonna pass it to these small containers where I'm gonna put my 4 treatments each. Okay, so now here we can see that my 4 treatments are almost done. Now I just have to add the gelatin to these 3 and the agar to this one. Each one of them has 10 milliliters of my sugar water solution, and this one, each one has 1 extra milliliter. This one has 1 milliliter of Gatorade, 1 milliliter of coconut water, and here it has Knorr dissolved in 1 milliliter of water. Every time I am talking about water, I'm talking about potable water. Okay, so now we're gonna measure the pH of our 4 treatments using these pH strips and this reference. We want the pH to be between 5 and 7, so let's hope we don't have to do any adjustments.
Hello, I am Maria Jose Espinosa, and I come to show my process of tissue culture at home. First, the plant I selected was the limon agrio, whose scientific name is Citrus aurantifolia for the ease. The culture medium I selected was Murashige's cock, as it is the easy to make and use. For this, the base formula was as follows: 100 milliliters of natural banana puree, 7.5 grams of grenadine, 7.5 grams of sugar, 0.6 grams of thiamine, 400 milliliters of distilled water, 50 milliliters of coconut water. The process began with the preparation of the culture medium, which was to make the banana puree with the help of distilled water, while dissolving the grenadine with distilled water being heated. Then the sugar and coconut water were added. Since there were no lumps, the puree and thiamine were added. Then the medium was placed in Gerber flask and allowed to solidify. For this plan, the medium was washed in 7% alcohol for 15 seconds, then washed 3 times with distilled water, then washed for 10 minutes with 30% chlorine, and then washed 3 times with distilled water again. As a result, the first days did not show significant changes. However, after 1 week, a little growth could be appreciated. Thank you for your attention.
Hello, teacher. This is Barbara Rilla in your Teacher's Culture class, and I'm going to present the short report in my Teacher Culture experiment of homemade culture. First thing I'm going to report is the materials I used for my experiment. Most of it I included into the picture, which are the Gerber flask, some gelatin, aluminum foil, alcohol, bleach, a candle for the sterility. I did use also bugs to prepare the area for the media once I started cultivating, and also a rice cooker to act as an outclay during the experiment. I did pick up some emptiness media from the lab, but I'm going to explain why I didn't end up using it later on the report. As for the selected growing media, I chose to use chicken broth, but since there wasn't any at my home at the time, I used chicken broth from the Gerber baby food and gelatin as a gelatinization for the media. For the seeds, I also prefer to use beans since they were easy to take and not hard to find. And if I can fail, I just could use more and take them from my kitchen. For the mirror preparation, as I explained it into my protocol, I did it on the stove by diluting Gerber chicken broth into 100 milliliters of water. This water was taken from a water bottle, so it was the most pure water I could find. And I add 4 grams of gelatin. And I said 4 grams because this was the quantity that was contained per bag of gelatin. So since I didn't have a scale, this was the easier way to do it. I sterilized everything by putting my flask and media into my rice cooker. As I mentioned before, this was to act as an outclay for safety reasons. Into the rice cooker, I also added about 1 to 2 centimeters of water with a few drops of bleach for the sterilization process. I cleaned everything before my family used it. It's important to mention that I didn't have the opportunity to take video, but I did take a lot of pictures. I was using always my lab robe, my gloves, and my safety glasses for this procedures, and also my mask, so I didn't contaminate the media. And here's important part to mention about the MS media that I took from the lab. It didn't gelify, so I didn't end up using it. I believe this was due because I didn't use the quantities of water. It required 50 milliliters, but I didn't have a way to exactly measure it. And I also didn't monitor the pH of the meat. So this was probably another agent because of the media didn't gelify. Well, everything was into the improvised autoclave or the rice cooker. I focused on cleaning my seed. I selected about 15 seeds from the bean bag and put them into a flask of Gerber with about 3/4 of water, soap, and a few drops of bleach, and agitated it for 5 minutes while I also monitored the rice because I was worried it could explode and something could happen there. Uh, this is my agitation process. While I was agitating, I was also checking the seeds and I noticed some of the seeds had appeared just like yellowish corners on the seeds. I believe that's effects from the bleach. So I ended up selecting for the media the healthier seeds. They're like this ones that didn't have that yellowish looking borders on the seeds. Oh, what's the other one? Okay. As for planting the seeds, after my media had solidified in the refrigerator, which I had previously labeled and now my family members not to touch anything or try to eat anything, I transferred everything to my room where I had set up a table with disinfectant, which was mostly composed of 70% ethanol, and took my first selected glass to there, and also my seeds had dried. As you can see, the area here around here is a little bit wet for the disinfectant. I also used candles for the sterile to keep the sterile media and to disinfect my tweezers here, which I was going to use to put them seeds into the flask. Once I put the seeds into the flask and I carefully select them, I forgot to take a picture of the full compound, but you can see that I put everything inside a box to keep the moist conditions and humidity and temperature control areas I could find from the videos and protocols that were put into the canvas. So this was the final setting for today. I would also like to mention that in my room, I make sure to put an air purifier so most effective conditions were kept. No one entered my room that it wasn't me. And most of the things I did was disinfect myself before entering the room just to keep it safe. Everything, as I mentioned, was disinfected before use. I did keep observing the changes every day, but I didn't notice any change until day 3, which was Monday. I planted everything on Friday, and on Monday morning, this is what I observed. One of the flats had peaceful roots in the top of it, which I believe was also my mistake because the seed was upside down and the part where the seed come out was facing upward. So the roots were coming to the top instead of going into the media. That was observed here. Here you see I was so excited and was trying to take some pictures of how the seed was growing into the media. But I also did notice that one of my flats had a black spot here, which I believe was contamination or fungus that did get into my media, and I was so sad for that part. The other 3 didn't have any problems with contamination. As for the 4th day, I kept monitoring everything, and I did notice more growth of the seed that was upside down, and you can see here how the seed was growing. And I did start to see something in the other 2 flats here, but it wasn't too clear of a picture to look at it. The media wasn't that clear that I could see the seed, but I ended up looking at something here. As for the other video, it did have the contamination. As for day 5, I had visible germination of 3 seeds out of 4. It wasn't clear here, but here is a little bit part of the growth. And even the flask that got the contamination started germinating the seed inside of it. So that was kind of weird. Here are some more pictures of the growth into the setting. Here you can see the roots of the octagon seed are all the way into the glass, and the other two have little stems coming out from from the media. I did with a flashlight try to see the roots inside the media, but didn't get a good enough picture, so I didn't put it. And as for the fourth glass that is right here on the back, I noticed too late that just half of the media had solidified, not all of it. I do believe it probably was the temperature of my room or some other thing that ended up melting the media in this glass, and the seeds didn't germinate in that one. Here are closer off pictures here. On the sixth day, there is also another germination. This one grew correctly. This is the stem, and the roots are right over here, somewhere around the media. And I was really excited because I got two healthy germinations without contamination. As for the things I would change or would work on doing for future culture media in my room, I would go for clearer media to have the roots more visible into the glass and actually keep my seeds start germinating correctly and everything's going fine with them. Second one would be more careful about the pH and the water quality and quantity that I put in the media so it doesn't affect the growth of the plants or have contaminants of it. I would also establish more skeptical conditions for the growth since one of my glass got contaminated. I'm not sure what that is, but I will be more careful about it. And finally, have the pH control. I didn't feel confident enough making my own pH control with the cabbage that some people mentioned on the video because I had already tried that once and it didn't go well. So I would probably try it again and have a pH control into my media. And that would be all. I still have the glass in my room and I don't know if we're going to use it, but this is it for the moment. Thank you, teacher.
So for the in-house embryogenesis culture, several steps were taken. First of all, an alcohol lamp was made. Here's the image. This was basically a glass container, alcohol, and cotton cloth. Another important step that was later used was a laminar hood. This was made with a cardboard box and inside aluminum foil. One really important step for the media is measuring the pH, so a homemade pH indicator was made with cabbage and boiling water. This was later on used for measuring the pH. The first actual step was selecting the area and sterilizing it, so the area for working was right next to where the autoclave would be so that the transfer would be immediate, and this area was sterilized with sodium hypochlorite and bleach. For the media, MS media was used along with a multivitamin tablet, and instead of the 50 milliliters of water, 40 milliliters were used and 10 milliliters of coconut milk were added. First, all of the ingredients were mixed except for the agar gel, and they were boiled. After they were integrated, the agar gel was put in and also boiled so that it could be completely dissolved. It is important to note that since this is not an sterile liquid, the pH needs to be measured before sterilizing in the autoclave. So a bit of the media was put into a tiny cup and then 2 drops of the pH indicator were put in it. The jar was covered with aluminum foil and then put into the pressure cooker, which would act as the autoclave, for about 30 minutes. The media was then left to cool down, and meanwhile the seeds were sterilized. They were put into a mixture of bleach, water, and a drop of detergent with continuous agitation. Once the media was cool enough, it was put into the jars to solidify inside the laminar hood, which was thoroughly cleaned. These jars were boiled and sterilized with sodium hypochlorite beforehand. When the media was solid, the sterile seeds were put into it with the help of tweezers. The tweezers were flamed before and between each seed to avoid contamination using the alcohol lamp. All of this was done in the laminar hood. A total of 4 jars received media and the seed. Since it is a bean seed, rapid embryogenesis is expected. Once the seeds were planted, the jars were covered and taken to a place next to a protected window. Here, no airflow would be in contact with them, but enough sunlight will be received. So it's been almost 6 days since the seeds were put into the media, and there's no apparent growth yet. The reason to it might be due to the usage of a lot of elements in the media that may have caused a biological shock in the seeds, as stated. However, it can be seen that there's no contamination, so it is still sterile, and that's a plus. Another reason that might have affected is that, as it can be seen, the media is not completely gel. I mean, it is gelified, but it's a little bit liquid. And at the same time, since coconut milk was used, it may have an impact in the reception of light, even though it's close to a window, and the media does not cover completely the seed, so it might also have to do with that.
Homemade micropropagation. The materials that we need are 1 pressure cooker, 2 small glass jars, 4 candles or a Bunsen burner to create an sterile environment, paper toweling, spray bottle containing 70% of alcohol solution, skin disinfectant, transparent plastic wrap roll, 2 tablespoons or a stirrer, 15 grams of agar, 15 grams of MS medium, 50 milligrams of water, 1 small bowl, 10 seeds, in this case I use lettuce seeds, 1 forceps, commercial blend, distilled water, and pH paper. Procedure. The first step is sterilization of the workplace and the material. First, you have to wash your hands and disinfect them with hand sanitizer. After that, you have to spray the solution of 70% of alcohol in your workplace to create a sterile environment. Then, place 4 candles or the Bunsen burner in the table in order to form a square so you can create a sterile environment. Add approximately 5 centimeters of water to the pressure cooker. Place the jars, the small bowl, the spoons, and all the material that you're going to use in the pressure cooker. Heat the pressure cooker for 15 to 20 minutes. For seed sterilization, you have to prepare a solution containing 5 to 10% commercial bleach. Place the solution in the flask and then place the seeds in the solution for 5 to 10 minutes. Finally, you have to wash the seeds with distilled water. The next step is to prepare the media. Once the material is sterilized, take them out from the pressure cooker and place them in the working area. Then, in 50 milligrams of water, add 15 grams of MS medium and stir it using the spoon until you have an homogeneous solution. Add 15 grams of agar to the previous mixture and stir it until you have an homogeneous solution. Use the pH paper to verify that the pH is between 5 and 6. Divide the solution in half and place approximately 25 milligrams of the solution in each jar. Place the lids in each jar and be careful to not close them entirely. Place the jars in the pressure cooker and repeat the process of sterilization. Once the sterilization is complete, wait until the media gels. The following pictures show how I did the procedure. When the media is ready, we have to do inoculation. For this, you have to use 1 spoon to place carefully 5 seeds in each jar and seal the jars with kitchen plastic wrap. Storage the cultures in a room with a temperature around 25 degrees. Supervise every day in order to record the process and to verify that there is no contamination. These were my final results after 1 week. We can observe germination in one of the jars, and I didn't observe any kind of contamination during the 7 days.
Hi, my name is Minerva and this is my homemade tissue culture experiment video. The materials I used were domestic bleach, detergent, distilled water, paper towels, flask, a glass, 70% ethanol, a homemade hood, lentil seeds, pH test strips, tweezers, baking soda, MS medium, and agar. The experiment was performed as follows. I washed my hands very well. I cleaned the area I will be working on. For seed disinfection, I washed the lentil seeds and took out the ones that didn't sink. I added a solution with 25% of domestic bleach and 70% of water to disinfect the seeds and agitate the container constantly for 10 minutes. Then I rinsed the seeds twice with distilled water. For the preparation of the culture medium, I dissolved the MS medium in distilled water. Measure its pH. Dissolve the agar with hot distilled water and melt it in a pot with heat. I put about 25 milliliters of the medium in each flask and close them. I let the medium solidify for about 1 day. For seeds inoculation, I flame the tweezers before taking the seed and place it in the medium. I flame the flask and lid as well. Next we have the results. On the first day after the inoculation, the seed coat broke and roots started to grow. On the second day, roots continued growing. On the third day, seeds started to grow shoots. On the fourth day, shoots developed leaves. Finally, on day 5, the shoots elongated. As we can see, none of the cultures was contaminated. My conclusions are that the medium had the right pH because it solidified, and it had enough nutrients for the seeds to achieve the germination process. Since no contamination was observed, we can assume that the experiment was performed in aseptic or at least clean conditions. Thanks for watching, and I hope you enjoyed the video.
First we gathered the materials, then we sterilized the Gerber containers in order to prepare the agar. We put 50 milliliters of water and agar and medium LB. Then we put it into the containers and left 1 day to rest and to solid them. Then we prepared with chloride the seeds, and then we put it on in the Gerbers. 3 days after, these are the results. 5 days after, these are all the results that the seeds were germinated as we planned. We have 4 Gerbers.
Hello, this is how I performed tissue culture at home. I used lentil seeds as they were easy to germinate. First, I started making the medium that the teacher provided us, mixing the MS media until it was completely dissolved, and then added the agar, heating the pot to reach a smooth consistency. After that, I poured 25 milliliters in each flask and sterilized them using the pressure cooker for 20 minutes. I took the flasks out and covered the top with plastic foil. I sterilized the lentil seeds using 1% sodium hypochlorite obtained from commercial bleach. I shook the seeds for 10 minutes. I did my hood with a cardboard box covered with aluminum foil. Before starting, I cleaned the inside with ethanol 70% and placed 3 candles inside to maintain the air sterile. I performed the culturing of the seeds, taking care to not contaminate the flask with the media. I flamed the instruments after using them with each seed. Finally, I wrapped once again the top of the flask with plastic foil and placed them beside a window that doesn't get direct sunlight. A week passed and my flasks never showed signs of contamination. However, sadly, the seeds never germinated. I suspect the treatment with the bleach was too strong and I killed them with it. If I had the opportunity to repeat it again, I would use a much lower concentration of the bleach or something different like ethanol for a brief period of time.
First of all, for this experiment requires the proper use of gown, mouth cover, antibacterial gel, alcohol at 70% and gloves to avoid contamination. The materials we need are jars, coconut water, tweezers, in my case granitine for the medium, chia seeds, and vinegar or baking soda if it's necessary. Also a box lined with aluminum and a pressure cooker that will be our autoclave. To prepare the medium, put to 20-50 milliliters of water. Add 7 grams of gelatin mixture and mix. If it's necessary, use the microwave for 20 or 30 seconds to be able to mix well until the solids are dissolved. Cover the bottle with aluminum to take it to the autoclave along with the other materials that will be needed. To sterilize for about 20-30 minutes. Once ready, the jar should be left near the window to receive light, but not direct light. It should be in a cool room.
The results were as follows. The first day was when the seeds were put in. By the second day, there was no changes. It was until the third day that it began to germinate, and so it continued for the fourth day.
For my tissue culture experiment at home, I decided to cultivate chickpeas. In order to do so, I needed cardboard box, aluminum foil, 70% alcohol, MS media, agar, containers, and a pressure cooker. To start, the MS media had to be dissolved in 50 milliliters of distilled water, and once it was done, the agar was added. In order to make a homogeneous mixture, it had to be heated. When the mixture was ready, it was poured into 2 containers. The next step was sterilization. Therefore, the pressure cooker had to be prepared with water under the cooking rack. The containers were half sealed and the top was covered with aluminum foil, and they were placed in the pressure cooker for about 20 minutes after the steam left through the pressure bulb. In the meantime, I lined the inside of the cardboard box with aluminum foil and disinfected the chickpea seeds for 10 minutes in a solution with a drop of detergent and commercial bleach. Once the time had passed, the chickpeas were washed with distilled water until no bubbles appeared. When the materials were sterilized, they were left so that the media would solidify, and the workstation was cleaned with 70% alcohol. Additionally, inside the homemade hood, a candle and the forceps were disinfected and placed inside. To cultivate the seeds, the first step was to sterilize the forceps, which was done by putting them on alcohol and then flaming them with a candle. Once this was done, the seeds were placed carefully inside the containers with the media and they were closed. The seeds started to germinate after 2 days. Here are some of the results. Homemade seed culture with peas. Here are the materials that we are going to use: chlorine, iodine solution, gelatin, fertilizer, water, coconut water, tweezers, and gloves. First, clean the peas with 10% chlorine solution for 5 minutes. Then immerse the peas in 1% iodine solution for 2 minutes. For the media, in 1 liter of water we put 30 grams of gelatin, 25 milliliters of fertilizer, and 50 milliliters of coconut water. When the gelatin is completely dissolved, we put it on a pressure cooker for sterilization, with some flasks and tweezers. We use the burner from our kitchen to avoid any contamination and proceed with the inoculation of the peas in the flasks. All of the instruments used during the experiment was sterilized with alcohol in 70% and burned in the burner. This picture is after 3 days of inoculation, and the flasks doesn't show any kind of contamination and it started germination. Unfortunately, the media started becoming really liquid because of the temperature of the days that have passed. So I decided to start new media with 40 grams of gelatin instead of 30. With this adaptation, the media was a little bit more solid, and also in 3 days we can evidence some germination from the peas. And during the whole experiment, we didn't evidence any kind of contamination.